Okay, so we'll go straight to the point. At each row, we will do like step 1 and then step 2. So step 1 is we will find the smallest and the second smallest element of the row above the current row. I will explain step 1 later. So when we come to step 2 here, we can see that this is accumulate the smallest non-adjacent value from the above row. So it's quite complicated, but in simpler terms, when we come to this cell, we will find the sum of the min path and at this cell. Okay, so what does that mean? At this cell, when we stand at cell number 9 here, we will look at the above row and we will check that what are the paths we can form that ends at this cell. So we can form either this or we can form 3 and 9, right? We cannot form 1 and 9 because it breaches the rule, so we cannot do that. But we have to choose, right? We have to choose whether this path or this path. So which one will we get? We will always account for the minimum value, right? We always want to get the minimum value, so we're going to choose 3 and 9, and then we want to modify this number 9 into 9 plus 3 here. It's 12. Okay, let me write with another color. It's 12. And when we come to 7, we will do the same. We will look all of the cells above. We will find the cell that has the minimum value from the row above, which is this row. Okay, so but we know that we cannot add 5 to this because it will breach the rule. We will either select 1, 7 or 3, 7. So which one will we get? Of course, we will get number 1 because it's smaller than 3. And this becomes 7 plus 1 will become 8. And this we will do the same. We will exclude this and compare 1 and 5. So obviously 1 is smaller than 5, so we will add 1 to this, which is 9. And then when we come to this cell, we will do the same as we did. This cannot form a path because it breaches the rule. So we remove this. We're not removing that, but we just don't even need to care about that when we are assessing this cell. Okay, so comparing 8 and 9, we will choose 8 because it's smaller, and we will add 8 to 10. It's 18. And then 6, we will do the same, excluding this. Comparing between 12 and 9, it will be 9 added to 6, it's 15. And then here's the 9, excluding this, we compare these two, and obviously we'll select 8, so it is 17. So when we have finished everything, like when we come to the final row, the last row, and then we will at this row, we will find the minimum value of this row, which is 15, and this is also our result. Okay, so the intuition in summary is that when you come to a cell, you must do 2 things. We must do 2 steps. Step 1 is that we will find the minimum value of the row above, right? We will find a minimum value of the row above, and step 2, we will add those 2 values. We will add the value of the current cell plus this min value that we found in step 1. We need to find the smallest, right? Because obviously we need to find the minimum value, so it's the smallest value in this row. But think a second, why do we need to find the second smallest? Why do we need to find the second smallest? Well, the answer is right in front of your eyes. When we stand at this cell right here, what are we going to add to 9? What are we going to add? We will obviously going to add the minimum value, right? The current cell is 9. We're going to add the minimum value of the row above, which is 1. We will add to 9. Oh, it's 10. No, it's wrong. It's obviously wrong because it breaches the rule. I have explained the rule. These two are in the same column and in two adjacent rows, so they cannot be added together. They cannot be the members of the same path. So we must not add 1 to 9. So what are we going to add? Obviously, we're going to add the second smallest, right? We're going to add the second smallest. We're not going to add the minimum anymore, but the second min or second smallest, whatever you like to call it. Because only in the case that the cell that contains the minimum value is also in the same column as the current cell where we stand at. Only in this case that we need to find the second smallest, because we cannot add 1 to this, right? We cannot add 1 to this. These are in the same column. We cannot add 1 to this. We must exclude this, and we find the minimum value in the rest of the above row, which means between 5 and 3 here. And obviously we're going for number 3 because it's smaller than 5. So it's number 3. It's number 3 right here. So that is the meaning, and that is the reason of why we need to find the second smallest. This part right here is an algorithm to find the smallest and the second smallest algorithm, and we'll just explain it here how it works. So let's say, for example, like we have an array like 1 and 5 and 2 right here, and so we want to find the 2 smallest values out of these 3 values of an array. So how do we do it? Okay, so at first we will initialize smallest as positive infinity, and second smallest is also positive infinity. Okay, so when we come to 1, we see that we ask ourselves, okay, is 1 smaller than smallest? It is, right? So we reassign smallest to 1, and the second smallest is also reassigned, but it's the smaller, it's the only value of smallest, so it's also plus infinity here. When we come to 5 right here, we see 5 is not smaller than the smallest. Smallest still stays the same as 1, and then second smallest, obviously 5 is smaller than positive infinity, so we will reassign second smallest to 5. Okay, but the interesting part is this. When we come to number 2, what will we do? When we come to number 2, right, we have seen 1, we have seen 5, and now we see 2. So we know that 2 is not smaller than the smallest. So the smallest still stays the same, but 2 is smaller than the second smallest. So we will update the second smallest. So smallest will stay the same, and then we will update second smallest to be 2. It's not 5 anymore. But let's say another situation, another case where we have like number 0 right here, right? Okay, so when we come to 0, what will we do? When we come to 0, you see that when we come to 0, we've already have 1, we already had 2, and now we see number 0. Okay, so what are our smallest and second smallest values right now? Obviously, it's not 1 and 2 anymore. It's 0 and 1, right? It's 0 and 1. But how can we implement this logic into our code? Okay, so we know that the smallest is always gonna be smaller than the second smallest, right? Because the name says it, smallest will always gonna be smaller than the second smallest. That's an obvious thing. But we've seen that there's another number that is even smaller than the smallest. So we know two things, right? Smallest is always gonna be smaller than the second smallest, right? And the new number is smaller than the smallest. So we see that new number is smaller than smallest, and smallest is smaller than the second smallest. And if we rewrite that into a better representation, we can see that new number is smaller than the smallest, and this is smaller than the second smallest. If we combine these two, we will get this. So now we know that this must be the smallest, right? This must be the smallest, because in order from left to right, the order of increasing, this must be the smallest, and this must be the second smallest. So this is our logic. It's that we will reassign the old smallest, the previous smallest, to be the new second smallest, and the new number is assigned to the smallest, right here. As you see here, smallest, the old smallest will be assigned to the second smallest, right? The old smallest, this one assigned to the second smallest, and the new number is the new smallest. So let's see right here, yeah, the new number is assigned to the smallest one. And that is the logic of this. Okay, so the biggest loop, this for loop, as we go through all of the rows, we will take, okay, so the time here is O of n with n number of rows, because this is an n times n grid, and at each row, right? At each row, we need to find the second smallest and the smallest. This takes an AND operation, and we also gonna loop through all of the columns in that row. I mean all of the cells in that row. So that takes another AND. So this is the time complexity. If you want, this is 2n. You can simplify this to 2n squared, but most of the time they're gonna remove the 2 here. So basically it's all of n squared, and the space, as we took advantage of the input grid, this grid, we took advantage of this, so we don't use any extra space, extra memory, so it stays at constant space. So this is it, and happy coding.